This will be a quite straightforward demonstration. So we have a spring and we will place that on to the rod. We now have a cardboard tube I've cut that we can place over the spring, and now we're going to place weights, individual weights, onto that spring until it compresses down to the top of that tube. So we'll just verify the masses. They're all roughly the same. That measures 24.27 grams. And we'll just lift that and try that again. And there we have 24.27 grams. So they're all roughly around the same. We're just going to place probes one at a time, and it will compress the spring, and eventually when we've got enough weight on there it will reach the top of the tube and trap the tube. So that's one, that's two, that's three, and four, and five, and six. And we can see that there's plenty of room yet. We need more weight to get it down to the top of that tube. So 7, 8, 9, and that's still free to move. 10, that's still free to move. 11, and that's still free to move. 12, I'm still not there yet. 13, and it's still free to move. 14, and now still free to move. I think one more, and 15, and that's now just hitting the top of the tube. So the weight there as 15 probes has compressed the spring down to the top of this tube. So the weight has stored that amount of energy into the spring. I've taken off the 15 masses now and replaced it with just one of those probes. So it's a 15:1 ratio. And then we're going to pull this down to the same compression of what the 15 masses did with the weight, and launch that one mass with that stored energy of the weight. I'll just do a couple in real time just so you can see how uneventful it actually is. The potential energy in the spring is half kx squared. As we launch it, that turns to kinetic energy, half mv squared, and as it reaches its peak of 6 centimeters, we now are under mgh, and as it falls, energy equals energy equals energy, and there's enough energy there to compress the spring almost down to the same amount as the 15 static individual weights.